What's up, eco-nerdlings? In this podcast, we're going to be discussing primary and secondary air pollutants. So primary pollutants include methane, ozone, dust particles, microorganisms, and chlorofluorocarbons, or CFCs. Now, those were a huge deal when I was in high school because a lot of the hairsprays that we had actually had CFCs in them. But those were basically made illegal, so they're not quite as much of a problem in hair care products and things like that. The causes, however, of primary pollutants can include factories, cars, wind and soil, volcanoes, forest fires, pollen, decaying plants, salt particles from the sea, as well as refrigerants. So looking at some of the primary air pollutants, we have some of the natural sources, which include volcanoes, and then we also have emissions from cars, different types of factories, things like that. So the major air pollutants that we're going to talk about are all going to be different types of chemicals that contribute to the pollution of the air. So the first one we're going to discuss are carbon oxides. Carbon monoxide is a highly toxic gas that forms during the incomplete combustion of carbon-containing materials. About 93% of the carbon dioxide in the troposphere occurs as a result of the carbon cycle that's naturally occurring. However, about 7% of the carbon dioxide in the troposphere occurs as a direct result of human activities or anthropogenic activities, including burning of fossil fuels. And unfortunately, it's not regulated as a pollutant under the U.S. Clean Air Act. So then we have nitrogen oxides as well as nitric acid. Nitrogen oxide forms when nitrogen and oxygen gas and air react at a high combustion temperature in automobile engines in coal-burning plants. Nitrogen oxide can also form from lightning and certain soil bacteria. Nitrogen oxide reacts with the air to form nitrogen dioxide. And then nitrogen dioxide reacts with water vapor in the air to form nitric acid and nitrate salts, which are components of acid deposition. So we also have sulfur dioxide as well as sulfuric acid. About a third of the sulfur dioxide in the troposphere occurs naturally through the sulfur cycle. However, 2/3 comes from human sources, mostly combustion of sulfur-containing coal and from oil refining and smelting of sulfide ores. Sulfur dioxide in the atmosphere can be converted to sulfuric acid and to sulfate salts that return to the earth as a component of acid deposition. We also have suspended particulate matter, or SPMs. These consist of a variety of solid particles and liquid droplets small and light enough to remain suspended in the air. So the most harmful forms of SPMs are fine particles with an average diameter of about 10 micrometers. We also have ultrafine particles that have diameters of less than 2.5 micrometers. According to the Environmental Protection Agency, SPMs are responsible for about 60,000 premature deaths a year in the United States. So that's the United States alone, and we're not even half as polluted as China or places like India. So the death tolls in areas like that because of SPMs are much, much higher. So there's also ozone, or O3. This is a highly reactive gas, and it's a major component of photochemical smog. It can cause and aggravate respiratory illnesses, especially asthma. So a lot of people have asthma nowadays, and a lot of times they actually get asthma because of all of the pollutants that are in the atmosphere. Ozone can actually also aggravate heart disease, and it can damage plants, the rubber in our tires. It can actually damage fabrics and paints as well. We also have volatile organic compounds, or VOCs. These are most of the hydrocarbons that are emitted by leaves of many plants, as well as methane. And about 2/3 of the global methane emissions come from human sources. Other VOCs include industrial solvents such as trichloroethylene, benzene, and vinyl chloride. Long-term exposure to benzene can actually cause cancer, blood disorders, as well as immune system damage. And that will prevent us from fighting off other diseases from pathogens like viruses and bacteria that our body would otherwise be able to fight and we would be able to recover from. But if our immune system is suppressed, we're not going to be able to fight off all of the pathogens as well as we could. Another major air pollutant is radon. And this is a naturally occurring radioactive gas that's found in some types of soil as well as different types of rocks. It can actually seep into homes and buildings sitting above deposits. So now we're going to talk about secondary pollutants. And secondary pollutants occur when primary pollutants react with each other. So right here we had our primary pollutants that we just got through discussing, and when those react together, they form the secondary pollutants. So industrial smog, which is the huge secondary pollutant we're going to be discussing, this is a mixture of sulfur dioxide, droplets of sulfuric acid, and a variety of suspended solid particles emitted mostly by burning coal. So in most developed countries where coal and heavy oil is burned, industrial smog isn't a problem due to reasonably good pollution control or with tall smokestacks that transfer the pollutant into rural areas. So basically, we're shipping our stuff somewhere else. So sunlight plus lots of car emissions gives us photochemical smog. So the photochemical smog is a mixture of air pollutants formed by the reaction of nitrogen oxides and volatile organic hydrocarbons under the influence of sunlight. So we have our VOCs, our nitrogen oxides, plus heat. So if you live in a very hot area, this is going to be even more of a problem, especially if it receives a lot of this, or sunlight. So and it gives us ground level ozone, other photochemical oxidants, aldehydes, and other secondary air pollutants. So this is an example of what photochemical smog looks like. This is something, if you live in the area that I do, which is Texas, and you've driven to Houston sometime, especially in the summers, you can see photochemical smog at times. So this one, though, particularly is Mexico City, and it's one of many cities in sunny, warm, dry climates with a lot of people that have cars, and they're constantly driving their cars, and it suffers from photochemical smog. You can also see this in LA. So outdoor air pollution and factors that influence it. So first of all, how can we reduce outdoor air pollution? Well, outdoor air pollution is reduced naturally by settling out, precipitation, sea spray, winds, as well as chemical reactions. Outdoor air pollution is increased by urban buildings. So basically really, really tall buildings slow wind dispersal of pollutants. They act kind of like mountains, and mountains can promote temperature inversions, and high temperatures promote photochemical smog. So temperature inversions we're going to talk about too. We have cold, cloudy weather in a valley surrounded by mountains that can trap air pollutants. This is to our left right here. And then we also have areas with sunny climate, light winds, mountains on three sides, and an ocean on the other. And those are susceptible to inversions. They're right here. So acid deposition is another huge problem that's been occurring. Sulfur dioxides, nitrogen oxides, and particulates can react in the atmosphere to produce acidic chemicals that can travel very long distances before returning to Earth's surface. So tall smokestacks reduce local air pollution, but they can increase regional air pollution. So basically, might not hurt the people that are right there, but we're just going to go ahead and pass it on along, and people over here are going to have our problem now. So acid deposition consists of rain, snow, dust, or gas with a pH that's lower than 5.6. So deposition can occur, like they were just saying, it can be dry in the form of dust, or it can be wet in the form of rain or snow, and then that can go into lakes, which can eventually seep into the ground. It can kill off plants. It can seep into the groundwater supplies, so all kinds of problems are associated with acid deposition. So acid deposition contributes to chronic respiratory diseases, and it can leach toxic metals like lead and mercury from soils and rocks into acidic lakes that are used for, of course, sources of drinking water. Another thing that happens, which we've talked about several times in this course, is mercury poisoning or the bioaccumulation of heavy metals. So one of the things that happens now is that especially pregnant women are warned, don't eat, different types of fish, especially, tuna fish, swordfish, because mercury can actually accumulate in their tissues. And that's a result of acid deposition because the heavy metals go into all of the lakes, and, that can get transported into the oceans, which of course can get transported into our food chains and food webs and end up eventually back in us. So this is a map that's showing some of the areas that are going to have acid deposition problems, that might have the problems in the future or that currently have problems. So green areas indicate potential problem areas just because the soil there is very sensitive. Yellow regions, which looking at the United States, the majority of the United States is either yellow or red. Yellow regions indicate potential problem areas because there's already air pollution and there's emissions that are leading to acid deposition. Now, areas in red already have current problems, and they also have their current problems in their lakes, their rivers, so they already have problems with their water supplies. So looking here, there's a huge problem pretty much right here in the Gulf of Mexico, as well as the East Coast right here. And then, of course, China, India have problems with acid deposition. So air pollution is one of several interacting stresses that can damage, weaken, or kill trees, as well as pollute surface and groundwater, which is something I was just discussing. So acid is deposited, it can basically harm trees, it soaks into the soil, it can prevent photosynthesis from occurring, it can, harm the roots of the plant, it can soak through the soil into our water table, eventually soak into lakes, get into rivers, which eventually, again, will all lead to the ocean. And that's how we see some of the saltwater fish that have mercury built up in their tissues. As far as, it's not just freshwater fish and lakes and things like that. It's basically becoming a problem everywhere. So what are some of the solutions? Well, of course, it's much easier to prevent this from occurring than to clean it up. So as far as preventative measures that we can take for acid deposition, we could reduce air pollution by improving energy efficiency. We could, of course, reduce our coal use. We could increase natural gas use, but that in turn comes with its own set of problems, like getting the natural gas, which can include fracking, and there's a whole slew of problems involved with that we've already discussed. We could use an increase in renewable energy resources. We could burn low sulfur coal. We could remove sulfur dioxides and particulates, as well as nitrogen oxides from smokestack gases. We could remove nitrogen oxides from motor vehicular exhaust, and we could actually tax emissions of sulfur dioxide. As far as cleanup goes, we could add lime to neutralize acidified lakes, or we could add phosphate fertilizer to neutralize acidified lakes. Both of those, though, lime is a little bit more natural than trying to add a bunch of phosphate fertilizer to it, which again has its own problems with all of the different, lives of different plants and animals that could affect. I hope you learned a little bit about pollutants. If you'd like to rewatch this video or any others for AP Environmental Science, you can visit my website at www.nerdlingscience.com. Well, this is the Queen Nerdling signing off for now. Stay nerdy till next time.